We're going to find the limit of f of x as x approaches infinity. We notice that f of x is a polynomial function. We know that polynomial functions are smooth and continuous. And to find the limit of this polynomial function as x approaches infinity, we want to know what is the value of f of x when x is very, very large. If we look at the graph of f of x, then we notice that as x gets larger and larger, the y value also gets larger and larger. And so we know that from the graph that the limit of f of x as x approaches infinity is positive infinity. But what if we don't have access to a graph, or we can't remember how the graph of a cubic function looks like? How do we find the limit of this cubic function? First, we are going to express f of x, or rewrite f of x as 2x cubed minus 5x plus 3 all over 1. And then we can multiply f of x by 1, and we know that when we multiply it by 1, the value will not change. But 1 can take many forms. So in this case, I'm going to find the x with the highest exponent, and it is x cubed. And what I will do is use that to multiply the numerator and the denominator of f of x by the same number. So I'm going to use 1 over x cubed. So notice that I have here f of x times 1 over x cubed over 1 over x cubed. We know that this is equal to 1, and so it is not changing the value of f of x. So far, our original function is f of x, that's the graph. Then we changed f of x to 2x cubed minus 5x plus 3 over 1. We know that that's still the same as the original. Now we are multiplying f of x by 1 in the form 1 over x cubed over 1 over x cubed. And if we graph, it is still in the same spot. So I know that these three equations are equivalent. Now, let's multiply the numerator and the denominator by 1 over x cubed. So we will distribute 1 over x cubed over the numerator and denominator. And this is what will happen. So we get here f of x is equal to 2 minus 5 over x squared plus 3 over x cubed all over 1 over x cubed. Now, if we are going to make x very, very large, then we know that 5 over x squared, 3 over x cubed, and 1 over x cubed, they are all very close to 0. So if we add 2, or if we simplify the numerator, we go 2 minus something very close to 0 plus something very close to 0, then the numerator will be 2. So we'll have here f of x is equal to very close to 2, a number very close to 2, over a number very close to 0. So now what we want to do is find out, if we want to find the limit of f of x as x approaches infinity, is to find out what is the value of this number, a number very close to 2 divided by a number very, very close to 0. So let's find out here. So let's say I have 2 and we want to divide it by a number close to 0. So let's say 0.1, we get 20. If I go closer to 0 by dividing 2 by 0.01, then I get 200. What happens if I get even closer to 0? So if I have 0.001, 1, then I get 2000. I make it 0.0001, now it's 20,000. So if as we make the denominator closer and closer to 0, um, f of x becomes larger and larger. So therefore, we say that the limit of f of x as x approaches infinity is also infinity. So I can write that down here. Okay, the limit of f of x as x approaches infinity is infinity.